alternating series test. So an alternating series test has a general form of the summation of -1 to power n-1 times bn, and n starts from 1, goes to infinity. We can break this guy down into smaller pieces. When n is equal to 1, you get -1 to power 0 b1. So here you have -1 to power 0 b1. When n is equal to 2, you get -1 to power 2 minus 1, which is 1, b2, plus when n is equal to 3, you have -1 to power 2, b3, plus the rest of the terms. So what do you see? This series can be written by its terms as b1 minus b2 plus b3 minus b4 and the rest of the terms. So what happens for the alternating series test? If you have a series like this, and if bn plus 1 is less than equals to bn, it means that they are decreasing. And the limit of bn as n goes to infinity is 0, then we can conclude that this series is a convergent series. Then the summation of -1 to power n-1 bn, n starts from 1 to infinity, is a convergent series. So you have alternating series test. Remember the general behavior, the general definition of alternating series. -1 to power n-1 times bn. bn plus 1 is less than equals to bn. It must be decreasing, and also the limit must be equal to 0. In that case, we can say that, hey, we have a convergent series. Let's take a look at one example together, see what do we have. In this example, you want to check the behavior of the summation of -1 to power n times 3n divided by 4n minus 1. N starts from 1, goes to infinity. So is this an alternating series? Does it satisfy the definition of alternating series? In general, here, if you list some of the terms of this series can be written as -1 to power 1 times 3 divided by 4 minus 1 plus -1 to power 2, 3 times 2 divided by 8 minus 1 plus -1 to power 3, 3 times 3 divided by 12 minus 1 plus the rest of the terms. Or you have -3 divided by 3 plus here you have 6 divided by 7 minus 9 divided by 11 and so on. So it seems like you have an alternating series, but is this a convergent alternating series? We have an alternating series. No doubt there. But is this convergent? To check to see if it's convergent, you need to check two things. First of all, you need to check to see if for the summation of -1 to power n minus 1, Bn, n starts from 1 to infinity. First of all, Bn plus 1 must be less than equals to Bn. It means that you have to have decreasing terms. And second of all, the limit of Bn as n goes to infinity, it must be equal to 0. Okay, take a look. This is your Bn, all right? This quantity here. Is this decreasing or not? To check to see if Bn is decreasing, to check if Bn is decreasing, we can either use algebra or basically use the derivative. To check if Bn is decreasing, we can use algebra or calculus. If you decide to use algebra, you need to build these terms one by one, 4n minus 1 and then 3n, and check to see what's the comparison between n plus 1 and n in the general term. Or you can do the calculus, take the derivative. So my Bn is equal to 3n divided by 4n minus 1. And if I write this guy as a function, 3x divided by 4x minus 1, what do I see here? The derivative is equal to 3 times 4x minus 1 minus the derivative of 4x minus 1 times 3x. You already know the derivative is 4. 4 times 3x, and then divided by 4x minus 1 to the second power. Then simplify as much as you can. F prime is equal to 12x minus 3 minus 12x, and then you have 4x minus 1 to the second power. So the derivative is equal to minus 3 divided by 4x minus 1 to the second. Since the quantity on the denominator is positive, and this guy on the numerator, negative 3, is negative, it means that the derivative is negative and it is indeed decreasing. So you can say that since f prime of x is negative, so f of x is decreasing. So the first condition is met. You have a decreasing term. Bn plus 1 is less than equals to Bn. What about the limit of Bn? Is this equal to 0? The limit of 3n divided by 4n minus 1 as n goes to infinity. If you divide everything by n, you get the limit of, or if you use L'Hopital's rule, you get limit of 3 divided by 4, which is 3 over 4. Oh, the limit is not equal to 0, everyone. So this series as an alternating series is going to be a divergent series. So let's go back up here. Even though you have an alternating series, this doesn't satisfy the condition for being convergent. This is a divergent series. So when you see questions like this, be careful. In this question, even though we have an alternating series, it does not satisfy the test for convergence. So how did we know it's a divergent series? Series, the summation of -1 to power n times 3n divided by 4n minus 1, n starts from 1 to infinity, is divergent. Why is that? Remember divergent test? In the divergent test, which was the very first test that we introduced in our class, it was the contrapositive of the theorem that we did. If you have a convergent series, the limit of the general term must be 0. So if the limit of the general term as n goes to infinity is not 0, then the series is divergent. So we just showed that since the limit of, here we go, you can use basically take the limit of -1 to power n times 3n divided by 4n minus 1, and just take a look at your bn, right? Your bn as 3n divided by 4n minus 1 as n goes to infinity. This is 3 over 4, which is not 0. So for sure you can say that, hey, this series is a divergent series. For the series itself, the limit of -1 to power n, 3n divided by 4n minus 1 as n goes to infinity. This limit is not 3/4, everybody. Just be careful here. It is cannot be found. This doesn't exist because you have -1 to power n, all right? If n is even, you get this case. If n is even, you have -1 to power even, which is 3n divided by 4n minus 1. When you take the limit n goes to infinity, it gives you 3/4. But if n is odd, you get the limit of -3n divided by 4n minus 1, n goes to infinity, which is -3 over 4. You have two different limits. What's the meaning of that? It means that the limit doesn't exist.